Okay, understanding what the derivative means. Our goal on this is to find the tangent line, find the slope of this tangent line to the x squared graph, as you can see below here, at the ordered pair 2, 4. All right, so the tangent line is the one in blue here. The first thing we could do is we could choose the second point that's on the same function, the x squared function. So if we were plugged in a 3 for our x value, we'd output a 9. So one way we could do it is we could start with this point and the point 2, 4, and we could calculate the slope of the secant line. y2 minus y1 over x2 minus x1 is going to give us the slope of 5. Now that's an estimation, but you can see that red line doesn't really line up quite with where our blue line is as far as slopes of lines go. So an alternative would be we could take this point that we had, we could slide it in closer along our function, the x squared function here. We can move it down to 2.5, which would output 6.25 as a y value to go with it. Then we could calculate the slope of that secant line, illustrated in red, and hugs in a little bit closer to where the blue line is. In this new red line, this secant line is going to have a slope of 4.5. Again, y2 minus y1 over x2 minus x1 to calculate that. But it's still not quite on top of this blue line. So it kind of stands that this one's closer as an estimation to where the blue line is than the first one. What we could continue to do is we could continue to creep this point closer and closer to the one we really care about, that 2, 4. The closer it gets, the better estimation we're going to get for that secant line to this tangent line. One way we could do it is we could do it numerically utilizing a table. So from the left-hand side, we could start with, say, 1.5, which would be over here. Then we could do 1.9, and 1.99 is almost on top of 2.4, 2, comma 4. As you can see, plugging it into the x squared function, we'd get 1.5 gets plugged in, we get 2.25. Calculating the slope of that secant line with the point 2,4, we'd get 3.5. When we move it closer, it goes to 3.9 for the slope of that secant line. 1.99, which is almost on top of 2, is going to give us 3.99. We could also do it from the right-hand side, where if we started at 3, that was the first computation we showed there. That line had a slope of 5 over on the left-hand side in the graph above. 2.5, the one that we just had up here, had a slope of 4.5. And then 2.01, just a little bit to the right of the point we care about, but almost right on top of it. If we did that calculation, the slope is 4.01. As you can see from both of these, the numbers are getting closer and closer to 4 on both cases. So we'd have a pretty good guess that the slope of the tangent line is actually going to be 4 based on the numerical values in this table. Now let's take a look at how we could algebraically do this. So algebraically doing this, what we want to do is we want to think about this as we have 2, 4, and then if we take a second point, we're going to call that 2 plus h, where h is going to be the distance in between an x value of 2 and whatever point we're going to utilize. By plugging it in to our function, the x squared function, we're going to get 2 plus h is going to be the y value squared is going to go for the y value of this ordered pair. So what I'm doing is I'm setting up 2 ordered pairs. We care about 2, 4, and then a second one, 2 plus h, is going to be the x value. When we plug it in, 2 plus h quantity squared would be the output y value that comes out of the x squared. What I'm going to do first to illustrate this is I'm going to make this into an ordered pair, but distribute out the y value there. So it goes 2 plus h, and then our y value would really be 2 copies of 2 plus h multiplied together. All right, with a little bit of simplifying down here, I'm going to multiply this out. We get 4 plus 2h plus 2h plus h squared. Or combining like terms, that's 2 plus h, 4 plus 4h plus h squared. Now I'm just representing this exact same y value in a different fashion, but it means the same thing. All right, so from here I'm going to think x1, y1, x2, y2, and fill into our slope formula because we want the slope of this line. All right, so our slope formula, the y2 values, 4 plus 4h plus h squared, minus the y1 value, 4, over the x2 value, 2 plus h, minus the x1 value is 2. Let's further simplify this. We can combine like terms. So we have positive 4 minus 4. So those are going to combine together. And in the denominator we have 2 minus 2. So those can combine together as well. This will result in 4h plus h squared all over h. All right, now as far as simplifying this down, our end goal is to pick 2 points that are basically right on top of each other. We can do this by using a limit. So if I go ahead and in front of this insert the limit as h approaches 0, basically meaning this distance in between our points becomes basically nothing, that the points will be on top of one another. As I go along, I'm going to go ahead and carry that limit as h approaches 0, meaning our points are on top of each other, but I can't really fill in 0 for all of our h's at this point. Instead, I need to do a little bit more simplifying down. I'm going to bring along our limit as h approaches 0, but I'm going to simplify by factoring out a common factor from our numerator, the h. That'll leave us with 4 plus h inside a set of parentheses and h in the denominator. And now we have factored, so we can cancel out or simplify by eliminating that common factor between numerator and denominator. What this allows us to do is, this will give us limit as h approaches 0 of 4 plus h, but at this point it's okay to replace the h with the 0 as we take this limit, because we're not going to be dividing by 0. So 4 plus 0 is the same thing as 4, so that means the overall slope of what we call the tangent line at x equals 0 is going to be 4. All right, hope this helps out as you're working on understanding this concept of finding the equation or the slope of a tangent line.